All right, we're going to take a look at our first integration by parts example here. So I would like to integrate the function x times natural log of x dx, just a regular old indefinite integral here. So I can tell just by looking at this that this is going to be, it's going to require integration by parts because, first of all, we can't use substitution. If you wanted to try and use substitution, we could maybe try a couple different things for picking our u. If we pick u simply just to be x, well, so if we pick u to be x, then that means that du is going to be 1 times dx. There's no way for me to account for this natural log of x in either my u or my du. So that doesn't work. We'd have to try something different. And we're going to run into the same problem if I choose u to be natural log of x. That means du is going to be 1 over x times dx. And again, there's no way for me to account for x here. I just have x to the first. This really is x to the negative 1 power. So that's not going to work either. So substitution doesn't work. I can also tell that this is going to be an integration by parts problem because we're multiplying two different kinds of functions. Here I've got x, which is x to the first, a polynomial or a power function, and then I have natural log of x, which is not a polynomial. It's a different kind of function. So usually when I'm multiplying two different kinds of functions, that's going to be what tells me, oh, this is an integration by parts problem. So the first choice that we need to make here in our integration by parts example is what is going to be our u. And we've got this little ranked choice right here for u. The best choice for u, if we have it, is a logarithm. Usually 99% of the time this is going to be a natural logarithm, which, hey, look at that, we have right there. So that's going to be our u. But in cases where we don't have a logarithm, then we move down and see, okay, do we have a polynomial or a power function? That would be our second choice. And then lastly, an exponential. This is almost never going to happen. In 99% of cases, we're going to see either a logarithm or a polynomial or power function. So that means that my choice for u is going to be natural log of x. So I'm going to do a little bit of scratch work off to the side. And then that means that dv is going to be everything that's left over. So that's going to be x times dx. So dv is going to be x times dx. So once we've made our choice for u and dv, as we've done over here, I now need to go and find du. Well, du is just the differential of u, and that's the same way that we did this when we were looking at u substitution. So the derivative of natural log of x, well, that's just 1 over x times dx. So there's our du. That's not really a problem. Next, we need to go and we need to find v. So this is going to look a little bit different because if I want to start with dv and work my way towards v, well, that's really an integration problem. What I'm really doing is I'm integrating both sides of this little equation right here. And when I integrate dv, that's really the integral of 1 times dv. And, well, I'm integrating with respect to v, so that's how I end up with v right there. And then I integrate the other side as well, this x dx, which, okay, this is x to the first. I can add my power rule, so adding 1 to the power gives me x squared. Divided by 2. We're not going to worry about the plus c here. That's going to come in at the end of our problem. So at this point, I've chosen my, let's highlight it here, I've chosen my u, my du, my dv, and my v. And I have everything that I need in order to go ahead and use my integration by parts formula. So integration by parts, I've got the formula way the heck up here. So I'm going to write it down just so that we have it in front of us. I like to have it, write it down, just it helps me memorize it. So I know that the formula says u times v minus the integral v times du. So u times v, I'm just looking at these guys up here. Here's u, here's v. So I'm going to try and keep this color-coded here. U is natural log of x times v. V is, we said, x squared divided by 2 minus the integral v. Well, what's v? We said, again, that's x squared divided by 2 times du. du is 1 over x dx. So times 1 over x dx. And this is my new integral that I want to evaluate. I'm not quite done yet. I still have a little bit more work to do, but hopefully, if we've done this correctly, the integral that we end up with right here should be simpler than the one that we started with. And it may not look like it at first, but we can do a little bit of simplifying. So I'm going to start over here with this part. I'm just going to rearrange these terms. I usually like to have the polynomial in front of the logarithm. I think it's just a little bit easier to read. So I'm going to bump that up front and say x squared over 2 times natural log of x minus the integral. I'm not going to integrate quite yet because I can simplify what's inside of my integral right here. This is x squared over 2 times 1 over x. Well, we can cancel a power of x. This is really x to the first divided by 2, or even if you'd rather take it a little bit slower, if we multiply straight across, x squared times 1, well, that's going to be x squared, and then 2 times x, that's over 2x dx. And then, of course, we can simplify that integral. So minus the antiderivative of x divided by 2 dx. The other thing I'm going to do real quick before I actually go and evaluate this integral, this is really 1x over 2, and I don't really like to have this fraction right here. I think it's an easy way to make a mistake. So I'm just going to factor out 1/2. So we're going to say minus 1/2 times the antiderivative of x dx. And sure enough, well, we know how to evaluate that integral. The antiderivative of x dx, well, that's x squared over 2. So I haven't been writing this left-hand side. That's just going to come down. So we should have x squared over 2 times natural log of x minus 1/2 times this antiderivative right here should be x squared divided by 2, and of course we can't forget about our plus c at the end of our indefinite integral. After this, the only last teeny tiny thing I can do, well, I can simplify this. I can go ahead and multiply that, write it as 1 factor right there. So my final answer is going to look like x squared divided by 2 times natural log of x minus x squared over 4 plus c. And there is our indefinite integral. So a few things that we'll have to keep in mind as we're working our way through these. First of all, of course, we'll need to know our integration by parts formula way back up here. And then we'll also want to make sure that we have this list nearby as you're working through your homework problems for what we should be choosing for you. The other thing I would keep in mind as you're working through these problems is remembering that this integral that we end up with should be simpler than the one that we started with. That's true for all of our integration techniques and derivative techniques too. If the integral that we end up with is more complicated than what we began with, if you perhaps chose the wrong thing for u or dv, then that's not helpful. We want to go back and look and try something different. So here's our first indefinite integral. We're going to look at another one coming up here that's a little bit more advanced. It's going to require some substitution on our part.